Hello everyone, we're discussing Newton's law of cooling. Rate of cooling rate of cooling is proportional to difference of temperature of body with that of the surrounding. Since temperature is decreasing, this B is negative. And in the last class, I gave you a question which was 60 to 55 drop. I don't remember the exact data, but let's say it was in 2 minutes. The question was, in what time temperature drops from 55 to 50 degrees. Temperature drops from 60 to 55 in 2 minutes, and then in what time it drops from 55 to 50. In the last class we used concept of constant of integration. We can also solve the whole thing with the help of limits. What is the concept of limits? First of all, when you integrate the whole thing, the integration should be in this form: dt upon t minus t naught b times dt. ये जो t minus t naught है ये denominator में shift करोगे because t and t they should be on the same side. Time moves over here. So when you integrate this, the integration was ln of t minus t naught. Integration of dt is t. In last class we used concept of C, constant of integration. We can also use concept of limits. Limits means starting from 0 to 2 in 2 minutes. Temperature changes from 60 to 55. I suppose surrounding temperature which I gave you was 30. Whatever it is, look at the concept. So temperature decreases from 60 to 55 in time from 0 to 2. Now do you put limits? Log upper limit 55 minus t naught, which is 30. This is the upper limit. T is 55, t naught is 30. Minus log. Now use lower limit. Replace t with 60. Surrounding is still what? 30. And on the right hand side you get B 2 minus 0. You can already see there is no need of constant of integration. This is log of 25 divided by 30, which is 2b. Log 25 minus log 30. What is log A minus log B? Log A upon B. Now, next time when temperature drops from 55 to 50, we can use the same setup. We'll write log of t minus t naught. On the right hand side it will be bt This time temperature drops from 55 to 50. 0 and T. When temperature is 55, let's say time is 0. We need what? In what time temperature drops from 55 to 50. So let's say 55 is 0 and 50 is T. So we can directly find T. In the previous method, when we are using constant of integration, T and T dash were two different things. I'll put the limits directly to save time. This is log of upper limit 50 minus T naught 30. 50 minus 30, 20 divided by, this is the upper limit, lower limit 55 minus 30, 25 B T minus 0. Upper limit minus lower limit, then you get log A minus log B, which becomes log A upon B. Now, from this, divide this and you get the value of T. So that's how you can easily find time in which temperature drops from 55 to 50. With the previous method, you can write first approach with the help of constant of integration, and with this you can write second approach with the help of limits. Note down this. B is known, put it here, and you will find T. You can also use a third approach, which is basically the approximation of the whole thing. Instead of integrating this, if you don't find any answer in terms of log, suppose they ask an objective question and there are options present and you don't see any log type of thing, it means they are looking for an approximated version, an approximated value of time, and this is how you do it. This dt, call it T final minus T initial. Mathematically dt is what? Small change, but let's say this is T final minus T initial divided by T. This dt, it's what? Time. Constant B minus of T naught. This T, what is T? T is continuously changing from 60 to 55. When you use integration, it takes care of the continuous part. 60, it becomes 59, then it becomes 58. The whole process, when you are using integration, takes care of the continuity. But in this approximated version, we say that this T, what should we take this T as? 60 or 55? Because temperature was initially 60 and then it became 55. So let's talk about average. So we write T initial plus T final divided by 2. What should be the temperature of the body? Average of 60 and 55. This takes this shape. With this, how can we answer the question? T final minus T initial. This is initial temperature, this is final temperature. It becomes 55 minus 60 divided by time 2 constant B T initial plus T final divided by 2 minus T naught. And then for the second part, T final is 50, T initial is 55. We need to find time. Constant B T initial plus T final divided by 2 minus temperature of the surrounding. From this, divide this and you can find value of time very easily. So when you divide, it gives you what? This is 50 minus 55 minus of 5 divided by T whole divided by minus 5 divided by 2. On the right hand side, B and B, they're gone. 55 plus 50, the average is 52.5. Average of 55 and 50 is what? 52.5 minus 30 divided by 55 and 60. Average is 57.5 minus surrounding 30. 5 cancelled. Your T is coming. This is 1 upon T. Shift 57 minus 30 is coming 27.5 divided by 22.5 multiplied by 2. So that's how you can easily find the value of time. The important part which you need to understand from this is when you calculate T, you can see that this is greater than 2. This is something we are interested in. Apart from the averaging approach, this is the approximated version. If they ask a subjective question, then always go for integration and all. If they are looking for an objective one, you can use this technique. The technique tells you what? In the Newton's law of cooling basically tells you that T is coming greater than 2. This is 27.5, this is 22.5. So T is definitely greater than 2, which means what? This 5-degree drop takes place in 2 minutes. Next 5-degree drop in the temperature by the same amount, 5, takes longer. So what is the final outcome of the whole thing? As a body cools down, time of cooling for the same drop increases. तो जैसे जैसे टेम्परेचर कम हो रहा है, अगर आप सेम अमाउंट ऑफ ड्रॉप की बात करेंगे 5, 5, 4, 4, 10, 10, तो टाइम धीरे धीरे क्या होगा? इंक्रीज होगा. Time of cooling is going to increase. We'll write a statement for this, but before that, note down this third method, especially this part. Write down the statement. According to Newton's law of cooling, as the body cools down, time of cooling for same drop in temperature increases. Time of cooling for same drop in the temperature increases. And this is something which you can also understand if you go for proper integration and then you plot a graph of T and T. I'll do that for you. If you can understand the whole thing, it's good. If you cannot, then somehow go through this integration approach through the lectures which I have sent you. Look here. This is dt upon t minus t naught, which is b dt. Its integration is what? Log of t minus t naught bt plus constant of integration c. Well, I'm giving you 40 seconds time. Get me t as a function of time. T as a function of time by removing log from the equation. So again, it's all about having knowledge of log function. It's all about how to integrate something like this. So you have to have this much mathematical foundation present, otherwise physics will look difficult always. Try to find an answer. You don't have to write it in the comment box. Once I present the answer, if you are close to it, you will write yes in the comment box. Let's see how many of you can do it. Look, this ln is log base e t minus t naught bt plus c. How do you remove log? That's how you remove log. What is this? E to the power bt plus c. Is what? T minus t naught. This gives us T as e to the power bt plus c, e to the power bt plus c plus t naught. Remember, b is negative. So this is the relationship between temperature of the body and time t. If anyone could reach this, then write down yes in the comment box. And always remember this approach. Base, power, and the product. Now, well, good. One of you says yes. Good. If I ask you to plot a graph of t and this t. Then how do we draw a graph where E type of thing is involved? Look here. Go down this much and then I'll plot a graph of t and t. Well, you can always figure out an approximated shape if you use simple logic. Let me ask you the logic. They are all graphs. Graph A, graph B, graph C, and graph D. Suppose they asked you this question in an objective examination and they give you 4 options. T is increasing, T is decreasing, T is decreasing, T is increasing. Now tell me which option is correct. Should not take more than 10 seconds. Which option is correct? Only 5-6 responses. This is what Newton's law of cooling. Newton's law of cooling means temperature is decreasing. If temperature is decreasing, that means A is not possible, D is not possible. Temperature is increasing, temperature is increasing. This B is a straight line and the equation is what? Y equals to mx plus c. But this is a graph based on E and therefore this B is also not correct. Correct answer is what? C. Graph comes down and is going to touch the horizontal time axis at infinity. Theoretically, we say that this thing is going to reach infinity, means it will take infinite time for the body to arrive at what temperature. I'll show you that also. This portion is what? I'll show you that. But put on this and then we'll draw a proper graph of C type. And this is the proper graph. Temperature of the body and time T. This is not the graph. This red line, it gives you T naught. So, graph starts from this point, something like 60, 70. Let's say initial temperature is 60. Surrounding temperature is 30. Then as temperature decreases, it can never go beyond 30. And therefore, I have drawn this red line. This is the graph. This black graph will meet the red line when T is infinite. You can see it here. This B is a negative number. Let's say -2. For the time being, let's say it's -2. Plus some constant plus T naught. So as you increase T, 2 minutes, 30 minutes, 40 minutes, 100 minutes, 1 hour, 2 hour, 3 hour, 4 hour. If you keep on increasing this T, this is becoming e to the power minus infinity, which is 1 upon e to the power infinity. which is 1 upon infinity. What is 1 upon infinity? 0. So this part becomes 0 and your final temperature becomes what? T naught. Theoretically, it takes infinite time for the body to reach the temperature of surrounding. Practically, just depending on the temperature difference, it will take a finite time, but theoretically, it will take infinite time. Now, the important part which Newton's law of cooling tells us is that in the example which I gave you, time was coming greater than 2. क्या मतलब है उस चीज का? देखना. Suppose temperature drops this much from this to this. In what time? For that, you need to arrive at this place. So this is a 5-degree drop. Suppose this is your 2 minutes time. Now, as temperature decreases, as body cools down, let's go for same 5-degree drop again. If you go for same 5-degree drop right here, this is again 5 degrees. But look at the time. What is this? This thing is T greater than 2. For same drop in temperature, as body cools down, it takes longer. So this is coming with the help of what? E to the power bt type of thing. Do you understand this part? Yes or no? And note down this. Write down calorimetry. In calorimetry, we are interested in things like you've got 100 grams of water at 60 degrees and you mix this 100 grams of water with 200 grams of water at 90 degrees Celsius. So we are interested in finding final temperature. You've got 1 kg of ice and then you put this ice in a water tank with a temperature of 20 degrees Celsius. So one is solid and the other is liquid. So what will be the final temperature? Things like these will be discussed in this calorimetry. Now, in thermodynamics, we developed the concept of C, which was dq and dt. And this C was called molar specific heat capacity. What is molar specific heat capacity? Amount of heat required to raise temperature of 1 mole by 1 degree Celsius. That was called what? C, molar specific heat capacity. In calorimetry, we discuss S, which is called mass specific heat capacity. What is mass specific heat capacity? Amount of heat required to change the temperature of unit mass by unit change in temperature. Amount of heat required to change the temperature of 1 gram by 1 degree. That will be called what? Specific heat capacity. Mass. In thermo with gases, this was C molar. Why do we get C and S, two different things? जब हम C की बात कर रहे थे, we are talking about gases. Gases के साथ क्या होता है? When you change the temperature, when you supply some heat, part of that energy increases or decreases internal energy, which was du. At the same time, volume change also takes place, which gives us what? Work. If you talk about a solid or a liquid, so when you supply heat, its volume changes but very little, and therefore we are not interested in that dW part. तो आप एक तरह से क्या बोल सकते हो कि जितनी एनर्जी आपने दी वो पूरी की पूरी बॉडी की इंटरनल एनर्जी को चेंज करने में यूज हो रही है. देयर इज हार्डली एनी चेंज इन वॉल्यूम इन्वॉल्व्ड. देयरफॉर we use a different term S, which is called mass specific heat capacity. Write down the heading and then a statement. Amount of heat required to change the temperature of unit mass by unit degree Celsius. Now you already know that you change the temperature by 1 degree Celsius or by 1 Kelvin, they both are what? Same. Change wise, 1 degree Celsius or 1 Kelvin, they both are same. So amount of heat required to change the temperature of unit mass by unit degree Celsius is called mass specific heat capacity. Now, this thing, calorie, which is present in this article, is basically what? If you have 1 gram of water, and you increase its temperature by 1 degree Celsius, then heat supplied is given a special name, which is 1 calorie. 1 gram of water, change the temperature by 1 degree Celsius, the amount of heat which is received by this water body is called what? 1 calorie. That's how you define calorie. But it also tells us that specific heat capacity of water. What is specific heat capacity? Amount of heat supplied for unit change in temperature for unit mass. So everything is that only. तो ये जो अपना स्पेसिफिक हीट कैपेसिटी है वाटर की, ये क्या होगी? 1 कैलोरी पर ग्राम per degree Celsius. Specific heat capacity of water is 1 calorie per gram per degree Celsius. अपने को एक बेंचमार्क, एक रेफरेंस फ्रेम डेवलप करना था. हाउ डू यू डिफाइन हीट, किस तरह से उसको क्वांटिफाई करें. हमने क्या बोला? 1 ग्राम वाटर, टेम्परेचर बढ़ा दो 1 डिग्री, जितनी एनर्जी दे रहे हो, इसको हमने क्या बोल दिया? लेट्स कॉल इट व्हाट? 1 कैलोरी. So this is specific heat of water. Now I'm giving you 30 seconds. Get me specific heat of water in terms of Kelvin, joules and kg. Note down this much and get me specific heat of water in terms of joules, kg and Kelvin. Well, some of you got confused, only few answers, and some of you, as I expected, will be confused in Celsius and Kelvin. Well, I hope you already know 1 calorie is 4.18 joules. 1 calorie is 4.18 joules divided by 1 gram, which is 10 to the power minus 3 kg. And when you go for degree Celsius, you do not use 273. As I told you, change wise, what is this degree Celsius? This is not temperature, this is change in temperature, and change wise Celsius and Kelvin both are same, and therefore 1 Kelvin. This is the value of specific heat capacity. 1 calorie, 4.18 joules, which is 10 to the power, and then grams is what? 10 to the power minus 3. And then degree Celsius, you wish you can write degree Celsius or Kelvin, they both are what? Same. Change wise, 1 Kelvin and 1 degree Celsius, they are what? Same. Remember this. Those of you who could not produce any answer, or those who gave the wrong one, do you understand this part? The whole thing? Yes or no? थोड़ा फीलिंग लेते हैं इस कॉन्सेप्ट की, क्या जरूरत थी अपने को सब डेवलप करने की. We'll start with a very easy question. 100 grams of water, (30°C), and you mix this thing with the 200 grams of water, but this is at a temperature of 50°C. When you mix these two waters, 30 and 50, after some time, you need to find final temperature of the system. 100 grams of water at 30, 200 grams of water at 50, you need to find final temperature. I'm giving you 30-40 seconds. In this much time you can answer something like this. This is a very small hint. Use the concept of conservation of energy. And this is very elementary and easy example. Let's see if you can produce this thing without my help. 30 seconds. Those of you who wish to write the question, they can write like this. 100 grams of water at 30 degrees Celsius. 100 grams of water at 30 degrees Celsius is mixed with 200 grams of water at 50 degrees Celsius. Find out final temperature of the system. Final means what? This 200 and 100 together, it will become what? 300. 200 and 100. दोनों मिलकर क्या बन गए? 300. And what is the temperature of this 300 type of thing? That's what we need to know. देखना कितना इजी अप्रोच है. कोई नहीं, आपसे पहला नहीं हुआ, बट इसके बाद के क्वेश्चन आप 10 सेकेंड्स में कर पाओगे. दिस इज 50, दिस इज 30. जिसका ज्यादा टेम्परेचर, इट विल बी द सोर्स. जिसका कम है टेम्परेचर, सिंक. Source, sink, high, low. Your final temperature, I guess you can understand this much, that it is going to lie between 50 and 30. 30 and 50. You're mixing these two things. Final temperature कहाँ आएगा? 60. Not possible. 30 के नीचे? Never. It will lie somewhere between 30 and 50. So we have already decided this thing, that final temperature is between 50 and 30. Source and sink. Source and sink means in this direction energy is going to flow, heat is going to flow. Energy is going to flow this way. अब इसको करने का तरीका क्या है? How much energy you are going to use? dq ms dt. थर्मो में अपन क्या करते थे? nc dt. यहां क्या हो गया? ms dt. Now look here. What is the concept of conservation of energy? In an ideal situation, if there is no heat loss to the surrounding, अगर यहां से 100 जूल एनर्जी निकलेगी, तो पूरी की पूरी 100 जूल कौन एब्जॉर्ब करेगा? सिंक. In an ideal situation. Real life में क्या होगा? एनर्जी यूज भी होगी. You're not interested in that. So 100 joules of energy flows in this direction from source to sink. That means इसमें से एक हीट को रिजेक्ट करेगा and the other one is going to receive. This is conservation of energy, and remember the simple line: heat rejected is equal to heat received. हर आदमी को पता है कौन heat reject करेगा. Source. कौन रिसीव करेगा? सिंक. Heat rejected is equal to what? Heat received. Now, जो अपना थर्मो का कॉन्सेप्ट था, रिजेक्टेड नेगेटिव, रिसीव पॉजिटिव, उससे परेशान मत होना. बिकॉज इफ आई गिव यू 100 रुपीज, मेरे लिए क्या बना? -100. आपके लिए क्या बना? +100. So can you write -100 is equal to 100? No. हम बात कर रहे हैं मैग्नीट्यूड, मॉड. So we'll be using 100 equals to 100. Technically मेरे से हीट निकली -100, आपने एब्जॉर्ब की +100, लेकिन अपन उस पार्ट में अभी नहीं है. वी आर सेइंग 100 is equal to 100. Now if you look at this heat rejected and heat received, कौन है जो हीट को रिजेक्ट करेगा? सोर्स. What is the formula when temperature changes by dt? Heat supplied, heat transfer is how much? dq. You always write this dq as delta q ms delta t if you wish. हालांकि उससे परेशान होने की जरूरत नहीं है. You can say it's a small integration. dq becomes delta q. What is dq? Small change. Small becomes what? Large change or large amount of heat supplied. dt, small change in temperature. Small becomes what? Large change in the temperature. अब यहां पर देखना, एक लाइन की कहानी है. What is the mass of the one which is rejecting the heat? Source 200. Specific heat S. dt. Normally dt is what? Final minus initial. If you go for final minus initial, you end up with the negative sign. Why? Because final temperature is less than the temperature of source. लेकिन मैंने आपसे क्या बोला? हम किसकी बात कर रहे हैं? मॉड, पॉजिटिव वैल्यू. तो आप क्या करोगे? कौन ज्यादा है, 50 और t? 50. Write down 50 minus t. क्या लिखा हुआ है ये? 200 grams of water with specific heat S, when its temperature decreases from 50 to T, this much heat transfer takes place. This much heat goes out. Amount. Negative sign क्या बता रहा है? Goes out. Heat received. किसने receive की? इसने. Sink. What is the mass? 100. Specific heat S. Now for this 100 grams, it receives the heat and its temperature increases from 30 to T. 30 to T. Remember, you need to keep both parts positive, left and right side. This is T minus 30. T minus 50 और T minus 30 मत कर देना, ऐसा बन जाएगा. I hope this part is clear, and then once this is clear, everything is quite easy. S and S cancelled. You don't even know, you need to know the value of specific heat, because you can see that it's getting cancelled. If it is getting cancelled, then what is the final answer? 200 into 50. This is 100 minus 30, shift plus 100 into 30. On the right hand side, you've got what? 100 into T plus this minus thing, 200 into T, shift there, 200 T. So your T is coming what? कर लेना solve यार. This is coming 100 cancelled. So this is coming 100 plus 30, 130, 100, 100, 100, 100 cancelled. This is coming 50, 230 divided by 2 plus 1, 3. That's your final temperature. Are you comfortable with this approach? Source, sink, positive, positive, कहाँ पर 50 minus T होगा, कहाँ पर T minus 30 होगा. If you are comfortable with this whole thing, then write down yes in the comment box. Fast. Now, if you look at the whole setup, how easy it is to produce this final temperature. What is 200? What is 200? M1. What is 50? T1. What is 100? M2. What is 30? T2. What is 100? M1. What is 200? M2. Or whatever, M1, M2, replace it. So your final temperature for this type of thing, if they ask in an objective examination, remember this. What is T final? M1 T1 plus M2 T2 plus M3 T3 plus whole divided by M1 plus M2 plus M3. You need to remember this much for any objective examination. There is no need of writing heat rejected, heat received, conservation of energy, T final, T initial. What is T final? And look at this format. Many times we have found a similar format. The same type of format was present in center of mass. Same type of format was present for molar specific heat capacity when you mix different types of gases, and the same thing appears over here. What is that? M1 T1, M2 T2, and 3 T3 whole divided by, just remember, कुछ लोग क्या करते हैं, किससे डिवाइड करना है, यही कंफ्यूज हो जाते हैं, and then they divide with T1, T2, T3. Well, you need what? T. And if you write T over here, then T and T cancel, and you're saying that temperature is equal to mass. बड़ा easy सा part है कि M cancel. Remember this. A result for you. Let's see the beauty of this result. Suppose they give you suppose we have been provided with 400 grams of water, and its temperature is 60. Let's keep it 100. देखना 100 grams of water at 30, 200 grams of water at 50, and 100 grams of water at 60. Now, the problem is that we have no idea what the final temperature would be. This is 60. Well, it will be definitely less than 60, more than 30, but it is going to lie, it will be either less than 50 or more than 50. This is the confusion. Now, what is the confusion? If final temperature is present between 50 and 60, थोड़ा सुनना समझना. If final temperature is between 50 and 60, then what is that which is the source? And what is that which is the sink? High temperature, heat supply hogi. They are at low temperature. They will receive heat and their temperature is going to increase from 30 to T, 50 to T. If this receives the temperature, then it is basically what? Sink. But if final temperature lies between 30 and 50, then 50 and 60 ये सोर्स है और 30 क्या है? सिंक. तो प्रॉब्लम क्या है कि अगर ये सोर्स है तो आपको लिखना पड़ेगा 50 माइनस टी. अगर ये सिंक है then t minus 50. ज्यादा माइनस कम. Remember like this. ज्यादा, everywhere you see is what? ज्यादा माइनस कम type of thing. Now, when you use this for the red one, if you decide that temperature, if you think that temperature is between 60 and 50, it's up to you. If you decide that we'll take temperature between 60 and 50, physics has no issue. Make it source, these two sink, write down the equation, ultimately calculation will give you the correct value. If T has to lie between 50 and 30, if you have taken everything correctly, it will give you that only. Similarly, if T is between 30 and 50, you make these two source, this one sink. If somebody takes this value of T between 30 and 50 and assumes that 50 and 60 are the source, तो वो आदमी क्या कर रहा होगा? T minus. But maths and physics will take care of this and will give you the final value of T. If T has to be between 50 and 60, it will come out. Not a big issue. कोई बड़ी चीज नहीं है. क्यों बड़ी चीज नहीं है? एक बार में समझना, अगर समझ पाओ तो. The point I want to convey is different one. Suppose somebody takes this value of T. You decide that T is between 60 and 50. Well, let's take first this one so that I can use the calculation of same calculation. If I go for this T, which is between 30 and 50, ये भी source है, ये भी source है. They both are source, then I will be writing what? 100 specific heat from 60 drop of T, 60 minus T. देखते हैं ना? That's how the equation appears. But if you decide that no, we'll go for this T between 60 and 50, then you will be writing what? This is the source, 100 into S, 60 minus T. Now, these two are the sinks. Sink means what? 200 S sink. Sink means temperature is increasing from 50 to T. ज़्यादा minus कम. T minus 50 plus, this is always a sink. 100 specific heat T minus 30. जो चीज मैं कन्वे करना चाहता हूं उसको पकड़ना. This one is for this T if it lies between 50 and 30. That means ये दोनों हीट सप्लाई करेंगे इसको. you get this. This equation is for this T. ये source है and दोनों sink हैं. But look at both. They are exactly same. What is this? 50 minus T. अगर ये 50 minus T left में ना होगा right में होता तो क्या लिखते? T minus 50. This is T minus 50. This is what? 50 minus T. But then I told you what? You don't have to worry about this or this. If they ask you this question in any examination, go for that. M1 T1 plus M2 T2 plus M3 T3. सोचना ही नहीं है कौन सोर्स है कौन सिंक है, जो होगा संभाल लेगा अपने आप को. And when I say that, if you take this value of T, but final answer lies between this, then maths will automatically take care of that. Automatically shift kar degi maths and we'll get the answer. Now tell me fast, do you understand the logic of this T and this T and why these two equations are same? Write down fast, yes or no. Write down a question, last question for today's class. 100 grams of water . 100 grams of water at a temperature of 20 degrees Celsius is dropped from a height of 10 meters. 100 grams of water at a temperature of 20 degrees Celsius is dropped from a height of 10 meters. Assuming after the drop it comes at rest, the entire volume of water comes at rest and no loss in energy takes place. I mean, there is no loss to the atmosphere. Then find out final temperature of water. I hope you understand my question. You've got 100 grams of water at 20 and you drop it from a height of 10 meters. The moment it comes here, there is no bouncing, there is no heat exchange to surrounding and all. Whatever energy came out of this collision is consumed by water only. In that case, what will be its final temperature? You've got 30-40 seconds to answer this. Let's see how many of you can. Look, what is source? mgh. Sink, water. Source is giving this much energy. What is source? Gravity, mgh. Sink with specific heat S receives the heat. Temperature increases from 20 becomes T. There is no loss to the surrounding. Initially water had this much potential energy. जब ये ग्राउंड से टकराया वो किसमें कन्वर्ट हुई? काइनेटिक. वो पूरी की पूरी काइनेटिक किसमें कन्वर्ट कर दी हमने? हीट में. देयर इज नो लॉस टू द सराउंडिंग एट ऑल. पूरी एनर्जी इसने कंज्यूम कर ली. दैट्स व्हाट क्वेश्चन सेज. This mgh is increasing temperature of this water 100 grams. Increases 20, low, T, high. Always high minus low. Always high minus low. You can see there is no need of m. You get your T minus 20 as G into H divided by S. T is coming 20 plus GH divided by S. 20 . Look fast. 20 plus G is 10, H is 10, S is 1. Now tell me fast, is everything correct in this? Tell me fast, is everything correct in this? I'll take 1 minute more. Just 1 minute. Is everything correct in this? Yes or no? Good. You know what is wrong? This one. Specific heat is 1. What? Calorie per gram per degree Celsius. But what is G? Meters per second square. H is what? Meters. And therefore, use proper value of S, which I gave you in terms of joules and kg. So when you go for that, this will be what? 4.18 into 10 to the power 3. देख लेना वही था, डिनोमिनेटर में 10 to the power minus 3 था shift, and it becomes 4.18 into 10 to the power 3. That is for grams conversion kg. Celsius, Kelvin doesn't make any difference. So that's how you solve this question. Concept क्या है? Conservation of energy. If you are comfortable with this approach, conversion of S and everything, then write down yours in the comment box and then you can leave. Thank you.